Welcome to the ML Platform Podcast, brought to you by Neptune.ai, the show where Piotr Niedźwiedź and Aurimas Gricinas, together with top MLOps practitioners, explore the world of internal ML platforms and MLOps stack components. Today we brought Eduardo Bonet from GitLab to talk about building MLOps capabilities as a one-person ML platform team.
The initial hypothesis is that data scientists do want to have code reviews, but they can't because the tooling is not there. I was using GitLab pipelines, and then I worked on migrating Cube to Kubeflow, and then I regretted it.
I had a thesis that we should think about MLOps as an addition to the DevOps stack.
Because that's what DevOps is about, right? Containing the flow of development in a single team.
Now onto the show.
Hello everyone and welcome to Machine Learning Platform Podcast. As always, together with me, I have my co-host Piotr Niedźwiedź, who is a CEO and founder of Neptune.ai. And today on the show, we have our guest, Eduardo Bonet. Eduardo Bonet is a Staff Incubation Engineer at GitLab, who is responsible for bringing all of the capabilities and goodies of MLOps to GitLab natively. Hi, Eduardo.
Hello there. Hello, everyone. Thanks for having me.
Would you mind maybe sharing a little bit more about yourself with our audience?
Yeah, sure. So I'm originally from Brazil, but I've been living in the Netherlands for a while, for 6 years now. I have a very weird background it's control automation engineering, but I've always worked with software development, but not always at the same place, so not the same thing. So I was a backend, front-end, Android developer, data scientist, machine learning engineer, and now incubation engineer. As I said, I live in Amsterdam with my partner, my kid, and my dog. That's the general gist.
What about your bike?
Which one of them?
You're
There's a
truly
couple
in
of them.
Amsterdam.
There's the daily, there's the sport, and there's the kid. There's a few of them.
Talking about your background more seriously, maybe because, to be honest, for me it is a term that I have never heard about. Incubation engineer. What it is about?
So the incubation department at GitLab, there's a few more incubation engineers, is a group of people that try to explore either new features or try to incubate new features or new markets into GitLab. We're all engineers, so we are supposed to deliver code to the code base. We are supposed to find a group or a new persona that we want to bring into GitLab, talk to them, see what they want, bring in new features into GitLab, and explore if they want those features do make sense in GitLab or not. So it's a little bit of like very early development of new features, and that's why the term incubation. So our engineers that are really more focused into putting the 0 to 80 rather than and then eventually that 0 to 80 will be passed into a regular team, which will do, if it makes sense, will do the 80 to 95 or 80 to 100.
So now you're kind of a single person in the team, right? Building out
Yes.
the MLOps capabilities.
Yes. So
can you give us a glimpse into your maybe day-to-day? How do you manage to do all of that?
So GitLab is great because I don't have a lot of meetings, at least not internally. And so I spend most of my day actually coding. Most of it is actually implementing features and then getting in contact with customers, either by direct contact with scheduling calls with them or by reaching out to the community on Slacks and LinkedIn or physical meetups. To talk to them what they want, what they need, what are the requirements. One of the challenges is that it's not a customer, like the people that I have to think about are not the users of GitLab, but are the people that don't use GitLab. Those are the ones that I'm building for. Those are the ones that I put in new features for, because the ones that are already at GitLab, they already use GitLab. The incubation is more how to bring new markets, new people into the ecosystem of GitLab, into the platform. So it's if I rely only on the customers we already have, that's not enough. I need to go out and look at users that want to use or maybe have it available but don't have reasons to use it.
But when it comes to, let's say, new capabilities that you are building, you mentioned that you are communicating with customers, right? So I would guess these are organizations that are doing regular software but would like to also use GitLab for machine learning, or are you straightly targeting some customers that are not yet GitLab customers, right? So users, probable users, let's call them.
Yes, both of them. Of course, the easiest one is that the customers that already have that already are on GitLab and they have a data science group within on that company, but that data science group doesn't find good reasons to use GitLab for. So I can approach them and see, and that it makes it easier because they can start using right away. But also brand new users that never had there were more data science users with more data science heavy workflow that want to. I'm trying to find a way to set their DevOps, their MLOps cycle, and yeah, GitLab can be an option for them.
And was it easy to narrow down to the capabilities that you're gonna build next? Like looking from the very beginning, let's say, when you started.
So in DevOps, you have decided DevOps lifecycle, and I'm more looking right now at the devs part. So right up until a model is deployed, is ready for deployment. So I've started with code review. I implemented Jupyter Notebook diffs and code review for Jupyter Notebooks a while ago. Then model experiments. This has been released recently, and now I'm implementing model registry. I started working on the model registry within the GitLab. So more on this, the first cycle, the ops. Once you have the model registry and once you have actually model registry, the ops, there are some things that you can add, but right now that's the main. So observability you can add later once you have the registry. So that's more part of the ops. But on the dev, this is what I've been looking at. Code reviews, model experiments, model registry, hopefully pipelines eventually.
And these requests came straight from the users, I guess. It's not something.
It depends. I was a machine learning engineer before and a data scientist. So a lot of what I do is personal pain. And I bring a lot of my past experience into looking at what could be, because I was a GitLab user before as a data scientist, both as an engineer and as a data scientist. So I could see what could be done with GitLab, but I couldn't because the tooling was not really there. And so I bring that. I talk a lot of customers. So MLflow or the model experiments was a feature that was suggested by customers in the past. Model registry as well. So there are a lot of things to be done, and it's hard to choose what to look for. And at that point is usually what I'm most excited about, because if I'm excited about something, I can build faster, and then I can build more.
And I have a question more on the organizational level. It is something that I've read at GitLab Handbook. For those who don't know what it is a kind of open source public wiki or set of documents that describes how GitLab is organized. And you can, like, for me, it is a great inspiration for how to structure different stuff from HR, engineering, product at the company, at the software company. And there was a paragraph about how we are starting new things, like MLOps support or MLOps GitLab offering for MLOps community, and you're an example like of this policy that they are starting from on one hand they are starting lean, so you're one man show, right? But they put the super senior guy in charge of it. That I found not like it sounds for me like a smart thing to do, but surprisingly, and I think that I've done this mistake in the past where I wanted to start something new. I wanted to start lean, so or rather put more a junior level person in charge because it is about being lean, right? But it was not necessarily successful because you need to. This problem is not defined. So my question is, how would, because you said yes, you're also an engineer. What are the hats you're effectively wearing to run this? Because it sounds like interdisciplinary.
Yeah, so there are many ways of kickstarting a new initiative within a company. Starting lean or incubation engineers are more for the risky stuff. So things that we don't really know if it makes sense or not, or they are more likelihood to not make sense than to make sense. For other cases, we can, like every team that we have, every team that is on incubation can also kickstart their own initiatives. They have their own process or of how to approach. They have more people. They have UX support. They have a lot of different ways. Our way is we have an idea, we build it, we ship it, we test it with users, and for that the hats that I usually have to wear is mostly the like backend, front-end engineer to deploy the features that I need, product manager to talk to customers, to enter the process of deploying things at GitLab, of understanding release cycle, how to manage everything around, how to manage process with other teams. A little bit of UX, but I prefer to delegate UX to actual UX researchers and UX designers. But the early version, I usually build instead of like asking a UX to or a designer to create a design. I build something and ask them to improve it. So that's more of the path that I've been
You
going
also have
towards.
this design system, right? Pajamas? I'm not sure what was the
Yes,
name.
yes, pajamas. They do. It does help a lot. At least to get the blocks going, the blocks moving, but still, uh, from the blocks to something that it's better within GitLab. You can still build something bad even if you have blocks. So the UX, I usually ask for UX once there's something aligned or something more tangible that I can look at. And then at this point, we already can ship to users as well, so they can have so the UX has feedback from users directly. So it's a bit of all, a bit of, and then the data scientist, most not really at delivering things, but when I chat with customers, it's really helpful that I was a data scientist, I was a machine learning engineer, because then I can talk in a more technical terms with them, on more direct terms. Sometimes, like the users are, they want to talk technical, they don't want to talk on a higher level. They want to get down to it. So that's very helpful. But on the day to day, that the hat of data science and machine learning is more for the conversations and for what needs to be done, rather for what I do right now.
Who would be the next person you would invite to your team to support you? Like if you can choose, what would be the position?
Right now, I think it would be a UX to bring in, and then more engineers. I think that's how it would grow this a bit more.
I'm asking this question because I think that what you do is a kind of extreme hardcore version of a ML platform team, where ML platform team in an organization is supposed to serve data science ML teams within the organization, but you have a broader spectrum teams to serve. So that's why that's why I'm asking how you're.
We have a data science, but we have both a data science and machine learning teams within GitLab now. So I separate both because it's one for more of like helping business make decisions, and the other for more product development to using machine learning and now AI as well. But so they are customers of what I build. So I have internal customers of what I build. But I try to build both in a way that we can use it internally, but also other customers can. It's great to have that direct dog fooding within the company. A lot of GitLab is built around dog fooding because we are using our product for literally everything, and having them use the tooling as well. The model experiments, for example, they were early users and they gave me some feedback on what was working, what was not. Notebook diffs as well. So that's great as well. Better to have
Do
them
you
around.
know if these teams, machine learning teams, are using some other third-party tools, or are they fully solely relying on what you have built?
No. That we are using what I've built is not enough to for a full MLOps life cycle or like the full broad. And teams are using other tools as well.
Okay. So you're kind of whatever you're building probably will be eventually replacing what we are currently
If
using.
if what I built is better than that specific solution that they need, yes, then they will replace with what I built. Hopefully,
Okay. So you're now at it for around 1.5 years, right?
yes.
Like, could you describe the success of your projects? How do you measure them? What are the
Yeah,
statistics?
I have metrics, internal metrics that I use for example, for Jupyter Notebook diffs or a code review. The initial hypothesis is that data scientists do want to have code reviews, but they can't because the tooling is not there. So we deployed code reviews. It was the first thing that I worked on, and there was a huge spike in code reviews after the feature was deployed. Even if I had to hack a bit how it was implemented. I implemented my own version of diffs for Jupyter Notebooks, and we saw a huge spike, a sustained spike. Like there was a jump and then a sustained number of reviews being done, more comments on Jupyter Notebook. That means the hypothesis was correct. They wanted to, they just didn't have any way to do that. But there's also a lot of qualitative feedback that I need to rely on because, like, as I said, it's not our current users that I'm looking at. It's new users that are coming in, and for that I use a lot of social media to get a little bit of like a temperature on what users want or whether they like the features, and also chatting with other folks. It's funny because I went for a pub with an ex-colleagues and a data scientist, and there was a bug on a Jupyter, and they almost made me take my laptop to fix the bug while there. And I did fix it in the next week, but I see now a lot more data scientists coming in and asking for data science stuff in GitLab than it was before.
And when you mentioned code reviews, do I understand correctly that what you mean is being able to display Jupyter Notebook diffs correctly? That
Yes.
would then kind of result in code reviews because
Yes,
previously you couldn't
exactly.
do that.
But is it in a way of pull requests, like with pull requests, or is more about, okay, here is a Jupyter notebook? Because I see a few, let's call them jobs to be done around it. Like one, I've done something, in Jupyter Notebook, maybe I was doing some data exploration, maybe I was doing data exploration and model training within Notebook. I see results and I would like to get feedback, maybe, where to learn, where I should maybe change something, like suggestions from colleagues. So it is one kind of use case that comes to my mind. Second, that I have not seen, but maybe because this functionality was not available, a pull request, so kind of a merge situation.
The focus was exactly on the merge request flow. So when you push a change to a Jupyter Notebook and you create a merge request, you'll see the diff of the Jupyter Notebook with the images displayed over there. A simplified version. What I do, I convert both Jupyter Notebooks to their Markdown forms, do some cleanup because there's a lot of stuff in there that's not necessary. And then I maximize information and reduce noise, and then I diff those markdown versions. And then you can comment and you can discuss the markdown versions of the notebooks. For the user, it doesn't matter. Like nothing changes for the user. There's nothing like the push, and it's over there. But for me, when I was data science, it's not even about the ones that use notebooks for machine learning. Those are important, yes, but for me, is also the data scientists that are more focused on the business cases, and where the final artifact of what their work is usually a report, and where the notebook is usually the final part of their report, like final technical part of their report. Because it's often, at least when I was at a scientist, we would review each other's documents, like the papers towards the end, or the reports, and there would be graphs and there would be stuff, but nobody would see how those graphs were generated, what was the code, what was the equations, was there a missing plus sign somewhere that could completely flip the decision being made in the end, and that's very dangerous. So I would say that for this feature, the most important, the users that can take the most out of it are not the ones that only focus on machine learning, but the ones that are more on the business side of data science.
This makes sense. This make like this concept of pull request code review in the context of reporting makes perfect sense for me. I was not sure, for instance, in model building, I have not seen much of pull requests to the. Okay, maybe if you have a library, right, that is shared, or feature engineering library, then yes. Pipelining, yes, but you wouldn't do pipelining necessarily in Notebook. At least it wouldn't be my recommendation. But yeah, makes sense.
But even in machine learning, the experimentation environments, I guess, benefit a lot before you actually push your pipeline to production, right?
Yeah, and there's another concept is that for code review, for me that was important, is that code review is where code culture grows. Is a Kickstarter to create a culture of development, a shared culture of development with your peers. And data scientists don't have that. Not that they don't want, is that if they don't code review, they don't talk about the code, they don't share what is common, what is not, what are mistake, best case or not. Code review for me is much less about correctness and much more about mentoring and just talking about what is being pushed. And I hope that with Jupyter reviews, code reviews, along with the regular code reviews and all of the things we have, we can push this code review or this code culture to data scientists in a better way, like allow them to develop this culture themselves, give the tools necessary.
I really like it, what you said. I've been engineers like all my life and almost all my life, and code review is, I agree, like it's one of my, if not the favorite part of it. Like if you're working as a team, right? And again, not about correctness, but about discovering how something can be done simpler, differently. Also, like making sure that a team understand each other code, and you have, and it is covered, right? So you don't depend on one person. It is not obvious how to really, for me at least, it is not obvious how to make it part of the process in when you're working on models. But I'm really see that we are missing something here as a MLOps practitioners. That's, yeah, I agree.
And then the second part that comes to the MR are the model experiments itself. That's the second part that I'm building into model into. I'm building it as an independent thing of merge requests, but eventually, ideally, this will be part of the merge request flow. So when you push a change to a model, it already runs hyperparameter tuning on your CI/CD pipelines, and you already display on the MR along with the changes what are the models, the potential models, what are the potential performances of each model that you can select to deploy your model. Your candidates, what I call, though each one is a candidate, And from the MAR itself, you can select which one's the model that will go into production or will become a model version that will be consumed later. So that's the second part of the MARs that we're looking at.
Yeah, so you're saying that this will be also part the report after HPO. Once there is a change, you will conduct HPO to figure out what is the quality of the what's potential quality of the model after those changes. So you can so you see it at the level of merge. I think we have something like that, right? When we are working on the code, so you get a report from tests, at least unit test that it passed, security test passed, okay, looks good.
The same way you have this for dev, where you have security scanning, where you have dependency scanning and everything, you're gonna have the report of the candidates that are being generated for that merge request. And then you have a view of what changed. You can track down where the change came from and how that did impact over time the model or the experiment itself. And then you can deploy to the model once the merge request is merged.
I have a question here. So it is about making your machine learning training pipeline part of your CI/CD pipeline. Because if I hear correctly, you're kind of treating it as the same thing, correct?
There are multiple pipelines that you can take a look at, and there are multiple tools that do pipelines. And GitLab pipelines are more thought up for the CI/CD, which is after the code is in the repository. And there are other tools that are better at running the any pipeline like Kubeflow or Airflow. So what a lot of our users do, they use GitLab for CI/CD once the code is there, and they trigger the pipeline. They use GitLab to orchestrate triggering pipelines on Kubeflow or whatever tool they are using, or Airflow or something. Usually one of the two. But some people also use only GitLab pipelines, and I used to do that. So when I was a machine learning engineer, I was using GitLab pipelines, and then I worked on migrating to Kubeflow, and then I regretted it because for my use case, my models were not that big. It was fine to run on the CI/CD of pipeline, and I didn't need to deploy a whole another set of tooling to handle my use case. So it was just better to leave it at GitLab. We are working on improving the CI, our pipeline runner. So now on 16.1, which is now, we have runners with GPU. So if you need GPU, you can use GitLab runners for that. And there are other needs that we need to improve to make them better at handling the data science use case of pipelines, because they start earlier than it usually does with regular, well, not regular, but software development.
And Eduardo, when you said GitLab runners support GPU now, or have you can pick up one with GPU, I'm not. We are, by the way, GitLab users as a company, but I was not aware that, or maybe I misunderstood it. Do you also provide your customers with infrastructure, or you're rather a proxy over cloud providers? How does it work?
I think this was with a partnership that we provide those. This is for GitLab for self. So there are two types of users of GitLab. One self-managed. You can deploy your own GitLab. For those users, we have GPU for a while. So self-managed users were able to use GPU, their own GPU runners for a while. Now, what was released in this new version is that we provide on GitLab.com. So if you're a user of the SaaS platform, you can use GPU-enabled runners as well.
Understand. Thanks. I wanted to really ask you about that because it was, by the way, how we maybe have not chatted a lot, but few months ago, maybe half a year or more, I shared a blog post on MLOps community Slack about relation MLOps relation to DevOps, and basically I had a thesis that we should think about MLOps as an addition to the DevOps stack rather than stack, like kind of independent stack next to DevOps stack that is inspired by DevOps but is independent. And like I'm curious from your perspective. You're in a DevSecOps company, right? How GitLab, at least today, present themselves. So you have a lot of DevOps customers and you really understand the processes there. At the same time, you have a lot of experience in data science, in ML, and you're running MLOps initiative at GitLab. What, in your opinion, we are missing in a traditional DevOps stack to support MLOps processes, use cases? What is really missing?
A lot of things. So for me, the difference between the MLOps and DevOps is there is no difference. It's the same thing. It's DevOps is like the art of deploying useful software, and MLOps is the art of deploying useful software that includes machine learning features. That's the difference between two of them. And so this including machine learning features, of course, we cannot fall into the trap as a DevOps company to say that, okay, you can just use DevOps. There are some use cases, there are some specific features necessary for the MLOps workflow that are not present on the traditional software development. I will call it that way, and that stems from the non-determinism of machine learning. So when you have code, you write the code, and you have inputs and you have outputs. You know the logic. The logic is written. It's over there. You might not know the results eventually, but the logic is there. And on machine learning, you can some models you can define the logic, but most of them you can just approximate what it's the logic that is happening over there. They learn from the data. So there's the process of teaching them, of allowing the model to extract the patterns from the data is one part that is not really present on traditional software development. So that's part of kind of like the user or the developer. They are developing the patterns of the input data to the output data. And then there's the other part is how do you know if it is doing what it's supposed to be doing? But to be fair, that is also present on DevOps. That's why you do A/B testing and things like that on regular software, because even if you know what the output of the change is, it doesn't mean that the users will see that in the same way. So you might, for example, you don't know if it will actually be a better product if you deploy the change that you have it. So you do A/B testing, you do user testing, yes. So that part is also present, but it's even more important for machine learning because it's the only way you know if it's working or not. On traditional software, you deploy the change, you at least know that if it is correct. Like you can test if the change is correct, even if you don't know if it does, like it moves the metrics or not. But you can test if it is correct or not. But for machine learning, that is the only way usually that you can implement tests, but tests are non-deterministic. So the regular testing stack that you use as software development don't really apply for machine learning because you're going to have a lot of flaky tests by the definition of machine learning. So your way of determining if that is correct will be in production. You can at most proxy if it works the way you intended to, but you can only know if it actually works the way intended at the production level. So it puts stresses in different places than traditional software development. It includes everything that traditional software development has, but it puts new stresses on different areas. And to be fair, every single way of development puts stresses on somewhere. For example, Android development puts its own stresses on how to develop, on how to deploy. For example, you cannot know what is the version that the user is using. That is a problem that is not specific, but very apparent on mobile development. And ML is another way another application of this. It will have its own stresses that will require its own tooling.
Feels like a great moment to interrupt the show and give you a 30 seconds pitch of Neptune AI. Okay, so we help with model metadata storage and management. That means you can log model metadata from anywhere in your pipeline and see the results in the web app. Organize and display it however you want. Search, debug, and compare experiments, datasets, and models. Save your production-ready models to a centralized registry and collaborate on your projects across the org. Oh, and we integrate with pretty much any MLOps stack. Just plug us in. For more, go to Neptune AI. Or check our docs. They're pretty good. I helped write them. Hope it was 30 seconds. Back to the show.
Maybe like talking more on examples, okay? Let's say that we have a like product company, SaaS company that has been so far has been not using machine learning, or at least on production level, right? But they are very sophisticated or following the best practices when it comes to software development. So CI/CD, let's say they have GitLab, they have a dedicated SRE team, they have engineering team, DevOps team. They are monitoring their software in production using, let's say, Splunk. Like I'm building the tech stack on the fly, but they are about to release on production two models. One, recommender system. Second, it will be, let's say, a chat bot for their documentation and SDK. There are two data science teams, but the ML teams are built of data scientists, so they are not necessarily skilled in MLOps or DevOps. And you have DevOps team. What, like, and you're a CTO, what would you do here? Like, shall DevOps team support them in moving it to production? Shall we start from thinking about setting up ML ops team? What would be your recommendation here?
My recommendation doesn't really matter about, but what I would potentially do is start with the DevOps team supporting and identifying within that specific company what are the bottlenecks that the existing DevOps path doesn't support. For example, retraining. But either way, to implement retraining, probably the DevOps team is the best one to work on that. They might not know exactly what a retraining is, but they know how the infrastructure is. They know how everything works over there. It might be that the DevOps team is split if there is enough demand eventually, and it becomes a ML platform in itself. But if you don't want to hire anyone, if you don't want to if you want to start, like we're talking about, start lean, perhaps picking up someone from the DevOps team from the area into supporting your data scientist could be the best way of starting.
The set of customers of GitLab is quite big, but let's talk about those you met, okay, personally. Have you seen DevOps engineers or DevOps teams successfully supporting ML teams? Do you see some like common patterns? How do DevOps engineers what is the path for a DevOps engineer to get familiar with MLOps processes and be ready to be called MLOps engineer?
It usually fails when one does something and ships to the other to do their thing. So let's say the data scientist spends a few months doing their model, and then I have a model, deploy it. That doesn't work really. They need to be involved early, but that's true for software development as well. So if you say that you're developing something, some new feature, some new service, and then you make the entire service, and then you go to the DevOps team and say, okay, deploy this thing. That doesn't really work. There are going to be a lot of issues on deploying that software. And there's a lot more stress in this when you talk about machine learning, because fetching data can be slower, or there's more processing, or I don't know. The model itself can be really heavy, so loading that into memory during during run. So it's better if they are at the process, perhaps not really doing anything, like not really working on it, but at the meetings and discussions, following the issues, following the threads, giving insight before, so that when the model is on a stage that it can be deployed, then it's easier. But for me, it's also important to the model not be the first solution that it's there. So deploy first, even if it's a bad one, a bad classical software solution that doesn't perform as well, and then improve. I see machine learning much more as an optimization for most cases than the first solution that you employ to solve that. So yeah, I've seen it being successful. I've seen also data scientist teams trying to support themselves and succeeding and failing. DevOps teams succeeding and failing at supporting, ML platforms succeeding and failing at support. So there's no. It will depend on the company culture. It will depend on the people that are on these groups. But communication usually at least makes these problems a little bit less. Involve the people before, not really at the moment you are deploying the thing.
And what is your opinion about these end-to-end machine learning teams, like fully self-service machine learning teams, them being able to manage the entire development and monitoring flow encapsulated in a single team? Because that's what DevOps is about, right? Containing the flow of development in a single team.
I might not be the best person because I'm biased, because I do end-to-end stuff. I like it. I think it reduces the number of hops you have to go. It reduces the number of the communication loss of team to team. I like teams that are multidisciplinary, even product, like especially product ones. You have your back end, your front end, your PM, and everybody together. And then you have like you deploy or something, you build a ship, or kind of like mentality that you are responsible for your own DevOps, and then there's a DevOps platform that builds. My opinion, I prefer when they take ownership of end to end, of really going and okay, we're gonna go from talking to the customer, of understanding what they need. Even the engineers, I like to see engineers talking to customers or our support, all then to deploying the feature, all then to shipping it and measuring it and iterating over it.
And what would be then the composition of this team, which would be able to deliver machine learning product end to end?
It will have, of course, its data scientist or a machine learning engineer. Nowadays, I prefer to start more on the software than on the data science part. So a machine learning engineer would be start with the software, then machine learning engineering, then the data scientist eventually to make it even better. For, of course, depending on all the use cases and everything that is involved. And the front end. So start with the feature that you're building, front end, back end, then add your machine learning engineer, then add your data science. Machine learning engineer can also do a lot more with the DevOps part as well. The important part is to ship fast, to ship something, even if it's bad in the beginning, and iterate of this something that it's bad, rather than trying to find something that is good and just deploy 6 months later. But at a point, you don't even know if the users want that or not. You deploy a really nice model that no one cares. Yes, for us, it's the iterate value. It's better. You tend to deploy better products by shipping small things faster rather than trying to get to the good product, because your definition of good is only on your head. Your users have another definition of good, and you only know their definition of good by putting things for them to use or to test. And if you do it small chunks, they can consume it better than if you just say, okay, there is this huge feature here for you. Please test it.
I have some questions that relate back to your work at GitLab. So one of them is you're now building kind of native capabilities in GitLab, including experiment tracking. I know that it's kind of implemented via ML Flow client, but you have all of the server underneath managed by yourself. How did you decide not to bring a third-party tool and rather build this natively?
It was a very known. Uh, it was a usually something that I don't do because I don't like implementing stuff myself. But like I mentioned, GitLab is we cater to self-managed to our self-managed customers, and GitLab is a Rails, mostly Rails monolith. So the code base is Rails, Ruby on Rails, and it doesn't use microservices. So it becomes kind of problematic to deploy another. We can, but then we have to, like, I could deploy MLflow behind the behind feature flag, like install GitLab and then we get MLflow at the same time. But then I'll have to handle how to install on all the different places that GitLab is installed at, which are a lot. I've seen, I think, on a mainframe or something. So I don't want to handle all those installations. And second, I want to be able to integrate across the platform. So I don't want to. I don't want model experiments to be its own like vertical feature. Like I mentioned, I want this to be integrated with the CI. I want this to be integrated with the merge request. I want to be integrated with issues. And if the data is on GitLab database, it's much simpler to cross-reference all these things. So for example, I already deployed last week integration with the CI/CD. So if you create your candidate or your run through GitLab CI, you can pass a flag and we'll already connect the candidate to the CI job, and you can have merge. You can see the merge request. You can see the CI. You can see the logs. You can see everything. So you want to be able to get to manage that, like on our side. It makes it better for the users if we own this on GitLab side. It does mean I had to strip out a lot of the features that MLflow server has. So for example, there are no visualizations in GitLab at this point. And I'll be adding them over time. This will come. I had to make the simplest or the chorus, like the what is distill this to the minimum to be able to deploy something that is useful. And over time we'll be adding. But that was the reasoning behind re-implementing the backend and using MLflow client while still using MLflow client.
You're calling this is part of iterate. You're calling it my minimal viable change. This concept of implementing how we call it, the chorus.
Yeah, I think it's even a little bit below that, the minimum, because now that it's available, users can tell what's needed to become the minimum for them to be useful.
So because it is private stuff. Because we are product team. We are inspired heavily by GitLab, and recently I was asked, okay, Piotr, we can to bring for us like minimal viable value to change that would bring value is too big to be done in one sprint. But we need to have I think it was something around webhooks and have setting some foundations for webhooks. So a system that can repeat the call if the system that should receive the call is down. So basically the challenge was about bringing some foundation for something that would bring value to the end user, but it wouldn't be. Would you do that? How would you do it at GitLab? Like, in order, for instance, to bring the value to the user, you need to set a kind of backend, implement something in the backend that wouldn't be exposed to the user. Would it fit to a sprint of GitLab at GitLab or not?
It does. A lot of what I did was not visible or not really useful. I spent 5 months working on this model experiments until it was a point where I could say I could onboard the first user. That was not dogfooding. So it was 5 months. I still had to find ways of getting feedback meanwhile. So either with my videos that I share every now and then to discuss, even if it's just discussing the way you are going to or where the vision. So you can get a feeling whether people want that vision or not, or are there better ways to achieve that vision. But it's work that it has to be done, even if it's not every work will be visible. Even if you go iterative, you can still go in iterative ways of work that it's not visible, but it needs to be done. So I don't know. I had to refactor how packages are handled on our model experiments, on experiment tracking. That, and it's more of a change that would make my life easier over time than to the user. But it was still necessary to be done.
So there is no silver bullet, because we are struggling with this type of approach, and was super curious how you do it, because at the first glance it sounded, for me at least, that every change has to bring some value to the user.
I don't think every change, because then you fall into traps, and then it puts some major stresses, like it puts some biases on your decision making to short term things that need to be delivered, and it puts things like code quality, for example, that will be pushed away on that line of thinking. But both ways are necessary. Like, you cannot use only one. Like, if you only use MVC all the time, you're gonna have an MVC in the end, and users don't really want an MVC. They want a product. They want something tangible. And there's no silver bullet. That's why software engineering is challenging.
Yeah, I've heard some research around, and it can be a segue to next theme of large language models. That maybe large language models would allow us to explain and in a way, or understand the way we can understand models. So there is opportunity in explainability space to use foundational models, but we'll see. So yeah, talking about, because if we are recording podcasts in 2023, it would be strange not to ask about it. Sorry, because we are asking because I think everybody is asking questions around large language models, but trying to talk not about impact on humanity, because all of that are fair questions, but here let's talk a little bit more tactically. So from your perspective and current understanding of how businesses can use on production large language models, foundational models, do you see, what would be, what are the similarities you see to MLOps? What would stay in a similar way? What is completely not needed? What type of jobs to be done are missing in traditional recent MLOps stack? So kind of a diff. We have MLOps stack. Okay, we had DevOps, right? We added MLOps. There was a diff. We discussed that, and we are adding large language models to the picture. What is the diff?
I think between LLMOps and MLOps, so there's two components here. So when you're talking about LLMOps, you can think as a prompt plus the model, the large model that you're using as a model itself, like the conjunction of them as a model. And from there on, it will behave very much the same as a regular machine learning model. So you're gonna need the same observability levels, the same things that you need to take care about on deploying that production. On the create side, though, only now we're seeing a little bit more taking prompts as its own artifacts that you need to version, that you need to discuss, that you need to provide the right people ways of changing that you need to measure, that you need to explore, that they will have different behaviors on different models, that any change. So the life cycle of the prompt itself, there are some companies that I've seen that are starting to implement it. So having a prompt registry where the product manager can go and change the prompt without needing a backend to go into the code base or a front end to go into the code base to change that themselves. That is one of them. And that's an early one, because right now, at least, you only have a prompt that you probably populate with data, or meta prompts or second layer prompts or build up. Yeah. But the further level is prompt generating prompts, and that level we haven't explored yet. So there's another whole level of ops over there that we don't know about yet. So how can you manage ops that generate, like prompts that generate prompts, or pass on flags? For example, I can have a prompt where I pass an option that appends something to the prompt. Okay, be short, be small, be concise, for example. So that development of prompts will become its own language, programming language, that we need to, like, functions defined as prompts. You pass arguments that are prompts in itself to these functions, and that will change a lot on how we do it. So a little bit of the agents now. That's a little bit of what I'm talking about. How do you manage your agents into your stack? How do you manage versions of agents, or what they're doing right now? The impact of them into the end when you have like 5 or 6 different agents interacting. So there are a lot of challenges that we don't really know about yet, because it's so early on the process. It's like 2 months that this became like actually usable on product.
Just wanted to add observation that in the most use cases, if it's on the production, there is human in the loop. Sometimes the human in the loop is a customer, right? Especially if we are talking about the chat type of experience. But I'm curious to see use cases of foundational models in the context where human is not available, like predictive maintenance, demand prediction, credit risk scoring, like things that you would like to truly automate without having human in the loop. How it will behave, how we would be able to test, validate those. Like, I'm not even sure whether we should call them models, right? Models and prompts and agent configuration. Another question I'm curious what you think. How, or will we, and if yes, how will we connect foundational models with more classical deep learning, machine learning models? Will it be connected via agents or differently, or not at all?
I think it will be through agents, because agents is a very broad abstraction that you can pretty much include anything as agents. So it's really, really easy to say agents, because, well, you can do that with agents or policies or whatever. But I think so, because that's how you provide more context. So, like, for example, search is very complicated when you have too many labels that you cannot encode in a prompt. So you need either a easy way of finding, like a dumb way of running a query that you have an agent or a tool. Some of them name this as tool as well. So you have a tool that you give your agent tools, basically. So this can be very simple as running a query. This can be very simple as saying something, or this can be more complicated as making a request to an API that predicts. And you could say that the agent will learn how to pass the right parameters to this API. For example, you'll still be using generative AI because you'll not be coding the whole pipeline. But some parts, it makes sense. Even if you have something working, perhaps it's better if you split off some into deterministic chunks, that you know what's the output of that specific tool that you want.
So my last question, I would play devil advocate here. So maybe GitLab should skip MLOps part and just focus on large language models ops part. It's it's going to be quite likely bigger market. In other words, will we need MLOps when we would be using large language models? Does it make sense to invest into it?
I think so. I think we're still learning the boundaries of when to apply ML, classic ML, and why every model has its own places where it's better and when it's not. And LLMs are as well part of this. I always have this. So there will be cases where regular ML is better. It might be that LLMs will become like you first deploy your feature with LLM and then improve with software and then improve with machine learning. So ML becomes the third level of optimization over there. I don't think LLM will kill ML. I don't think that's like nothing kills anything. Like some people have been saying that Ruby would be dead and COBOL would be dead and Java would be dead and I don't know. Decision tree would be dead because now you have neural networks. Even if it's just to keep the simplicity, sometimes you don't want those more complicated features. You want something that you can have control of, that you know what was the input and the output. Whether GitLab should focus on LLMOps and MLOps, I think that's a tough question. But I think for now, at the beginning, right now, until we start learning what is LLMOps, MLOps is a better focus because we have a better understanding how this fits into GitLab itself. But it's something we are thinking about, like how to use, because we're also using LLMs internally, right? So we are dogfooding our own problems with how to deploy AI-backed features. So we are learning with it. And yes, those could become a product eventually. Those could become prompt management could become a product eventually. But at this point, even for us to handle our own models, the model registry is more of a concern rather than a prompt registry or whatever.
So Eduardo, it was really nice talking with you. Do you have anything that you would like to share with our listeners?
Model experiments that we've been talking about is available for our users on GitLab as 16.0. So if you want to test it out, I'll leave a link to the documentation. If you want to follow what I do, I usually post a short YouTube video every 2 weeks or so of advancements. So there's a playlist that you can follow as well. And if you're in Amsterdam, drop by the MLOps community meetup that we organize.
Thank you, Eduardo. Super glad to have had you here. And also thank you to everyone who was listening, and see you in the next episode.
The ML Platform Podcast was brought to you by Neptune.ai. If you'd like to learn more about ML platforms and MLOps, check our blog at neptune.ai/blog. Follow us on LinkedIn or subscribe to our YouTube channel. Also, check out how we help teams solve MLOps challenges with our experiment tracking at neptune.ai. To get notified of future episodes, follow us wherever you get your podcasts. Thanks for listening and see you next time.